Okay, folks, so this is going to be the working solutions for the polarity prediction. We're using our electronegativity values. The question that they're going to ask you is we're going to find the polarity or the type of bond. So by that they mean, is it ionic, is it covalent, is it, and we subdivide covalent into non-polar covalent and polar covalent. So we're using our electronegativity values. We're starting with A, and we're looking for the electronegativity value of S, which is 2.5, and for Cl, which is 3.0. We take one from the other, so 3.0 take away 2.5, so we're always taking away the biggest number, because that is the more electronegative, and when we do that piece of maths, we get 0.5. Our rule was, one of our rules, if it is greater than 0.4 but less than 1.7, then this is what we call a polar bond. So the SCl bond is polar. On a diagram to show that then, the element that is the most electronegative, which in this case is the chlorine, gets this little, it's called a delta negative. It has an ever so slightly negative charge. What this means is if you could see the electrons in the shared pair, they'd be all the way over to chlorine. And then if the Cl minus is delta negative, then this is ever so slightly positive charged. Remember, the next step, if you're not a polar covalent molecule, would be you're fully ionic. So it would mean that the chlorine would have taken the electrons completely, no shared pair anymore, and then we give that a full negative charge. So looking at our next one, N is 3.0 and O is 3.5. So again, we're taking more electronegative from the less electronegative, and again, this is giving us a 0.5 number. So our rule up here is still applying. So this is a polar bond. We're not talking about polarity in molecules, we're just talking about finding what type of bond we have. So again, if you had to